MS Ramaya University of Applied Sciences.
Hi students, let us discuss Nyquist criterion on signal sampling. The aim of the experiment is study the Nyquist criteria for sampling and reconstruction of signal. The Nyquist theorem, also known as the sampling theorem, is a principle that engineers follow in the digitization of analog signals. For analog to digital converter ADC to result in a faithful reproduction of the signal slices called samples of the analog waveform must be taken frequently. The number of samples per second is called the sampling rate or sampling frequency. Any analog signal consists of components at various frequencies. The simplest case is the sine wave, in which all the signal energy is concentrated at one frequency. In practice, analog signals usually have complex waveforms with components at many frequencies. The highest frequency component in analog signal determines the bandwidth of that signal. The higher the frequency, the greater the bandwidth if all other factors are held constant. Suppose the highest frequency component in Hertz for a given analog signal is f max. According to the Nyquist theorem, the sampling rate must be at least 2 f max, or twice the highest analog frequency component. The apparatus required are Syntec 2151 kit with power cords, digital oscilloscope, probes and connecting cords. Observe the connection diagram. The procedure is: connect the power cord to the kit, keep the power switch in off position, connect 1 kHz sine wave to signal input, connect sample output to 4th order low pass filter input and sample and hold output to 2nd order low pass filter input. Switch on the kit's power supply and oscilloscope. Turning on the supply will randomly select the sampling frequency. Connect the power cord to the kit. Keep the power switch in off position. Observe the output waveform at outputs of both low pass filters. By pressing sampling frequency selector switch, change the sampling frequency from 2 kHz, 5 kHz, 8 kHz, 10 kHz, 20 kHz up to 40 kHz. Sampling frequency is 1/10 of the frequency indicated by the illuminated LED. Observe how sample output and sample and hold output changes in each case. Also observe output of 2nd order low pass filter and 4th order low pass filter. Output waveform. Sampling frequency is 2 kHz. Figure 1.2 shows sample output and 4th order low pass filter output. Figure 1.3 shows sample and hold output and 2nd order low pass filter output. Output waveform. Sampling frequency is 40 kHz. Figure 1.4 shows sample output and 4th order low pass filter output. Figure 1.5 shows sample and hold output of 2nd order low pass filter output. The observations made are: set sampling rate of 2 kHz with 50% duty cycle. Instead of onboard 1 kHz sine wave onboard signal, apply a 3 kHz 2 volt peak to peak sine wave from external source or function generator to the signal input of sampling circuit. Observe the output waveform of the two low pass filters. Increase the sampling rate from 2 kHz gradually up to 40 kHz. Observe the output waveforms recorded at both low pass filters' output.
Hi students, this is an experiment to analyze and learn the Nyquist sampling criterion. In that there are three ways. One is undersampling and critical sampling and the oversampling. Apparatus required for the current experiments are Syntec board. This is Syntec 2151 board. We need to connect a power supply through this power adapter, and using this socket we have to connect, and this is the power supply switch. In this board we have this crystal oscillator going to generate sine wave that 10 kilohertz and to 800 kilohertz, and we extract 1 kilohertz sine wave and we consider this as an analog function generator for this experiment. we are going to generate different sampling frequency using this circuit. This circuit is having oscillator, crystal oscillator, and we have an analog mux through which we can select different sampling frequencies, different frequencies from 400 Hz to 20 kilohertz, 400 kilohertz to 20 kilohertz. We can select desired sampling frequency using the analog mux, and once the output of the analog mux is divided by the 10 times, then the frequency is reduced. 20 kilohertz will become 2 kilohertz. Then using the magnitude comparator and the latch, we are going to convert an analog sine wave into a series of pulses. Those pulses are used for the sampling circuit. There are two ways of sample amplifier. The other one is the sample and hold amplifier. Sampled output will be fed into the analog filters. One is the second order filter, the other one is the fourth order filter. Output of these filters are reconstructed analog waveform out of the sampled waveform. Digital oscilloscope, main power switch of this digital oscilloscope is this one, and we have this is a two channel oscilloscope, channel 1 and the channel 2. These are the magnitude adjusting knobs, and these are the horizontal position adjusting knobs, and this is the time scale adjusting knob. Probes and the connecting wires. Let us start the circuit connections using the Cytec 2151 board. Let us start the connection. The first connection would be from the output of the function generator to the signal input. The second connection would be sample output to the input of second order filter. Take the probe of digital oscilloscope, connect to the first channel, and this is the positive point of the digital oscilloscope, and this is the negative, and here negative will be connected to the ground and positive will be connected to the output of the function generator. Then the second probe will be connected to the second channel. Positive will be connected to the output of the filter, and the negative will be connected to the ground. This completes the connection. Now switch on the power supply. Here this is the switch to select the different sampling frequency. Now it is at 400. Now it is shifted to the 200 kilohertz, 100 kilohertz, 80 kilohertz, 50 kilohertz, and 20 kilohertz. Then through the selected frequency will be passed through the analog mux and fed into the frequency divider. Frequency divider divides the frequency by 10. So if I select frequency 20 kilohertz, then it will be divided by 10, then its output will be 2 kilohertz. That 2 kilohertz sine wave will be fed into the magnitude comparator and the latch. That sine wave will be converted into pulses of 2 kilohertz, and that would be the sampling frequency for the current experiment. Let's switch on the power supply of digital oscilloscope. After switching on the power supply of the digital oscilloscope, press on the auto set button. Channel 1 will be representing by the yellow line and channel 2 will be representing by the blue line. Channel 1 will be showing the input waveform and the channel 2 will be showing the output waveform. Now the sampling frequency is at 2 kilohertz and the input signal will be at 1 kilohertz. So it is critically sampled and passed through the second order filter. Now the next will be higher sampling that will be shifted by this button. Now sampling frequency will be at 40 kilohertz and the input signal will be at 1 kilohertz. So here the reconstruction is perfect and this is oversampling case. Similarly, you can select the other frequency and observe the reconstruction quality of the signal. By this we complete the experiment.
At MSR, you arc your imagination further.